Hello and welcome lads and lasses to my first video on this channel. My name is Tamil Chaudhary, aka Dr. Chaudhary, the only doctor with a PhD. Not really. Today this video is going to be all about 2D shapes. Get your pen, paper and minds ready as we are jumping right into the video. Hello and welcome to the video. As you can tell from the intro, we are doing 2D shapes. Now let's go over the basics with some formulas, basic formulas. A square or a rectangle, base times height. And then this formula can work for a parallelogram as well. A parallelogram, the formula is also base times height. But then some people might wonder why. This is the base, we will name it as B, and this is the height, perpendicular height. And why does this formula work? Because if we cut this triangle and then move this triangle over here, you can get a rectangle, and that's why it's called base times height. Now, other formulas we need to consider are also the triangle, base times height divided by 2, a trapezium, A plus B times the perpendicular height divided by 2. We're not talking about this height, not the slanted height, we're talking about a perpendicular height, a straight height. And then obviously circle, pi r squared. Now, let's start off with a basic question that I am going to show you guys how to do. Oh, and by the way guys, sorry for using headphones. The microphone that I bought doesn't work with the camera, so this has to make do for the meantime. And also guys, sorry for the delay of the whiteboard. Amazon were being absolute turds delaying the whiteboard. They managed to bring me everything like the tripod, microphone, all the fancy equipment, but not basic equipment like a whiteboard. It's really annoying. Alright, so the question here would be, find the area of the shaded region. Now, there's one common way that people like to approach this type of question. Firstly, I'll find the area of the big rectangle. Which is equal to base times height, the base times the height, 8 times 9, which is equal to 72 centimeters squared. Now, to find the area of this shape, it's a compound shape. It's made of two shapes, essentially a rectangle right here. And yeah, so this rectangle is 4 by 2. And I'm following the base times height rule. 4 times 2 is 8 centimeters squared. I won't write that because I can't be asked. And then to find this length right here, we'll do 4 minus 2, which is 2. So this is essentially a square. Still follow the same principle. Base times height, 2 times 2, 4. Then to find the area of the L shape, we do 8 plus 4, which is equal to 12 centimeters squared. And finally, to find the area of the shaded, we'll do 72 minus 12, which is equal to 60 centimeters squared. Alright, this is a question for you guys to do. Find the area of the shaded region. Have you followed the intro and listened to it? Have your pen and paper ready? Oh, this is the time you need it now. Now, I'm sure this question was pretty easy to most of you, but those who did not manage to answer the question, this is how you guys do it. First, find the area of the big rectangle, 8 times 6, which is equal to 42. No, 48, what am I doing? Yeah, 42 centimeters squared. Alright, that's the area of the big rectangle. I can't do mental maths. And then you'll find the length of this side. So if you bring this up here, all the way up here, you know this part is 1 centimeter. Because this can follow up all the way up. And then this segment, you can put it all the way up here and say this is also 1 centimeter. It's because this gap is 1 centimeter. I'm trying to visualize it better by moving it up along with the 8 centimeters. So then we can find this length by doing 8 minus 1, which is 6 centimeters. And then we'll do the same here, visualize it better, move this here, this is a 1 centimeter gap, move this here, this is a 1 centimeter gap as well. And then 6 minus 1, that is a 4 centimeters, this length right here. My handwriting is atrocious, don't mind me, but education is all worth it. Now, since we know this is a 6 by 4, we'll do 6 times 4, which is 24 centimeters squared. And then to find the area of the shaded region, we just do 48 minus 24, which is equal to 24 centimeters squared. Now they might ask you a different question. We're saying, what's the percentage of this shaded of the area? Gosh, I need to write a script. Angle in comparison with the area of the big rectangle. So we know this is 24 centimeters squared, and we know the big rectangle is 48 centimeters squared. 24 over 48 times 100 is 50%. How is 50%? So if we do, let me just remove this right here. If you do 24, the area of the small rectangle over the area of the big rectangle, we can times 100, because this is how you find a percentage. We know these 24 is a multiple of 24 is a factor of 48. So then we can cancel this out, because 24 times 2 is 48. Then we can just cancel those out, and then 1 over 2 times 100, that's basically saying 0.5 times 100, which is 50%. Now all these questions were easy. Next question will require a calculator and it's a bit hard. Alright. So the question will be here. Find the area of this hexagon. Now you guys might be looking at like, what's the formula for area of a hexagon? Well, you don't need a formula. This can be splitted into 4 shapes, and that's a hint. So guys, try this question out. And I gave you the hint, it can be split into 4 shapes, and one of the shapes is in this list. Find out which one. Now, hopefully that you attempted this question, and if you found the answer, well done. If you haven't, well, I'm gonna go through it with you. So then, the 4 shapes I'm talking about, if you plot a midpoint right here and draw a line straight through, bear in mind this is a regular hexagon. If I haven't stated that already, then you can pause the video right now and do it. And then, yeah, if you plot a midpoint right down, and since it's a regular hexagon, this side will be 3 centimeters. This side will be 3 centimeters. And it will go all the way around 3 centimeters, 3 centimeters, 3 centimeters. And then since this is a midpoint, this can be split into 1.5 centimeters, because 3 divided by 2 is 1.5 due to it being a midpoint. So this distance plus this is 3 and it's halfway. And then since it's midpoint, we'll go halfway through the diameter of this hexagon. This will be 4 centimeters as well. Now can you see a trapezium, a trapezium, a trapezium, and another trapezium? Gosh, I love trapeziums, why not? So we can take this trapezium right here, draw it out, and examine it further. So here will be 1.5. Let me make it bigger actually, so it's way easier to show the working out. I'm going to do this right here. Alright, so this will be 1.5 centimeters right here, and this will be 4 centimeters right here, and this slanting will be 3 centimeters. Now essentially, based on this formula, a plus b times height, we know what a is, we know what b is, we don't know what the height is. We can't not use this as the height because this is slanted. We're talking about perpendicular, vertical height, like a straight one, like this one right here. We need to find this. So essentially, what you do, for those who are doing like higher maths and GCSEs, you would know what I'm going to do. So this makes a right angle triangle. Well, I know it doesn't look like it, but if I can make a line straight, if I use a ruler, it will look way better. So this is right angle triangle. We know that this is 3 centimeters, the hypotenuse. And then to find this length right here, we just do 4 minus 1.5, which is 2.5 centimeters. And once we have that, we can label these sides as A, B, and C. And then Pythagoras Theorem comes into play. A squared plus B squared equals C squared. Now what we can do here, is rearrange to find what B is. So minus A squared here, minus A squared here. That will essentially be B squared is equal to C squared minus A squared. Now we plug in the values. B is equal to C is equal to 3 squared. And put squared here so it doesn't confuse people. Minus what A is, 2.5 squared. Then we can essentially simplify this. We still haven't got what B is because we still got a square here. So what we do is square root both sides. So this will lead to square root of 3 squared minus 2.5 squared. Now this formula comes really handy with graphs and all that, finding the distance of lines. But we'll come on that in a later video, possibly a very later video. So then once we have that, I'll move this right here. So the answer to that would be root 11 over 2. Now that's what B is. This is the height. Root 11 over 2. Now we got the height, we got A, we got B, we can find the area. So the area would be 1.5 plus, that's a times, then we got that out, 1.5 plus 4 in the brackets multiplied by the height root 11 over 2 divided by 2, and that would equal to, too many 2's but whatever, that would equal to 11 root 11 over 8 centimeters. Now I'm just going to rub this out really quickly. So we know that it's 11 root 11 over 8, so that's the area of one trapezium. So the area of one trapezium is equal to 11 root 11 over 8, and we've got 4 identical trapeziums here. We just times it by 4, and you don't need to use a calculator for this, because what you can do, these cancel out because 4 fits into 8 twice, and then essentially your final area is 11 root 11 over 2 centimeters squared, and that's how you do that. Thank you guys for watching this video on 2D shapes. Next video will most likely be on 3D shapes. Remember to subscribe, and also always be learning. Hello and welcome to the video. And as you can tell from the intro, thank you for watching this video, and